Hello, ladies and gentlemen, and welcome to Lesson 6 of Atomic Structure, Part 1. This is our second last lesson in the booklet, where we talk about the first half of structure of the atom. Next lesson will naturally be the second half of structure of the atom, and then we'll be finished with this booklet, ready to move on to the next one. So, as per usual, you'll see here the knowledge check. So hopefully your teacher sent this through to you. Otherwise, you can do it either in the digital copy of the booklet, or you can use a paper copy of the booklet if you have it. Or again, if you just have a scrap piece of paper somewhere, you can write the answers down there as well. So what I'd like you to do is pause the video, answer the questions, and we'll take up the answers in a minute. So hopefully you've had a chance to go through those, to write down those answers. We'll go through them now. I would like you to correct the answers that you have. So if they are correct, you can just give it a tick. If they are incorrect, I would like you to write down the correct answer so that you do have it. So starting with question 1 here, the charge of a proton is +1. Or if you've done +1, that's all right as well, but it is +1. The charge on a neutron is neutral, or it has no charge. The charge on an electron is -1. Or again, -1 is fine as well. You do need to have that 1 in there for both the proton and the electron, as it will become important as we go later on. Define atom in Greek. So the definition, what does that word mean? It means indivisible or cannot be divided, would work as well. The charge on the nucleus itself is positive. You do not need a number for this because every nucleus has a slightly different positive charge. The name of the model J.J. Thomson proposed for the atom. J.J. Thomson proposed the plum pudding model. What happened to the fired particles during Rutherford's experiment? If you remember, in Rutherford's experiment, he fired the alpha particles, the positively charged particles, at the gold foil, and some of them bounced back or were deflected. And the last question of the knowledge check, Rutherford's proposal for the electrons. Where did Rutherford think the electrons were? He thought they were in orbits around the nucleus. All right, so hopefully you have all of those answers in. If not, correct the ones that you have wrong so that you do have all the correct answers down. So today, again, we're going to talk about the structure of the atom and the main structure. It will be something that you will have to memorize, but we'll come back and revisit it several times. So a little bit of review. The word atom comes from the Greek word atomus, meaning indivisible, meaning it is the smallest building block of matter. Remember that everything that has matter that has mass, is made from matter. So, atoms are smaller than your cells. They are the smallest thing that we really know about. A cube of sugar, for example, 1 centimeter by 1 centimeter by 1 centimeter, but the size of a dice, if you can't think of the size of a cube of sugar, has more atoms inside of it than there are people on Earth. So that is how teeny tiny an atom is. All atoms are made from the same basic parts called subatomic particles. If you think of submarine, goes under the water, under the atom, under the surface of the atom, and the same basic structure. However, each element in the periodic table has a different quantity of each subatomic particle. You might recall quantity is a scientific word for number. So each element has a different number of each of the subatomic particles. So for example, iron has a different number of protons than sulfur, which has a different number of protons than oxygen, which has a different number of protons than sodium. This is how we tell them all apart, is by these different numbers of subatomic particles. There are more than 3 subatomic particles, but the 3 that you need to worry about for here are the protons, the neutrons, and the electrons, and you will need to know the charges of them as well. So if you need to, pause the video, take some time, memorize those, and then come back. Now would also be a good time to go through and refresh your idea of those first 20 elements that you need to know. There are lots of good quizzes online that will help you refresh your knowledge of them, see how well you know them. You need to know the name, symbol, name, mass number, and atomic number for the first 20 elements. So find an online quiz or something, ask someone at home to quiz you, take some time, refresh your memory on that, because it has been a little while since we've talked about it, and then come back to the video and we'll continue on. All right, so as I said, today we're going to be going through the structure of the atom. So in previous lessons, you would have heard about the basic structure, how the nucleus was in the middle, protons and the neutrons were in the nucleus, the electrons were on the outside. Today we're going into a little bit more detail about that. So as I said, we know atoms have a positive nucleus in the center, where we find the protons and the neutrons. So in our atom, in the middle, we have our nucleus, which is filled with protons and neutrons. The electrons, which are, again, remember, negatively charged, orbit or go around the nucleus in a specific height, at a specific energy level. Special areas called energy levels or shells. So they are moving in that constant area in a constant direction in that specific area. If they have more energy, they'll go to a higher energy level. If they have less energy, they'll go to a lower one, but each energy level can only hold so many electrons. So the negative electrons are attracted to the central positive atom. So we know the negative electrons are attracted to the positive nucleus by what we call electrostatic forces. This is, hopefully you remember from earlier in the year, when you dealing with static electricity and things like that, that positive and negatives attract. So opposites attract. The neutrons, which are also in the nucleus, have no charge and no effect on the protons and the electrons. They're actually there to help hold the protons together, because too many protons too close together don't want to be so close to each other, so the neutrons help to balance that out. The electrons are tiny compared to the proton and the neutron. The proton and the neutron are about the same size. So we have our proton, our neutron, and our electron, which is so small that you would be able to see it here. So if this proton here were to be the size of a football, I feel like you all know what a football is, the electron would be the same size as a grain of sand. So you would not be able to notice that grain of sand compared to the football. And inside of an atom, they're also really, really far away. So if I go back to this diagram here, so if I have a football proton, a football neutron, and several of them, these grain of sand electrons going around, if it was that size, the distance between the nucleus and the closest electron would be 2 miles. So the nearest grain of sand to our football would be 2 miles away. Naturally, if we want to draw them at that proper scale, it wouldn't fit in your book, it wouldn't fit on this page, so that we don't draw them to scale for that reason. But it is something to keep in mind that that is the difference in size between them. So here, there's two videos to watch here. In your digital copy that your teacher should have sent through for you, you can click on the links to watch these videos, and they will have a lot more, be able to describe it a lot clearer than I can in with the technology I have. So watch those two videos, far more entertaining than me, and then come back to this one and we'll continue on with the booklet. All right, now that you've watched those videos and you have a better understanding of how an atom is put together, I would like you to give a go to labeling this atom. So you'll see there are 1, 2, 3, 4, 5 things you need to label. And there are 5 words here that you need to label. So proton, nucleus, neutron, electron, and energy level. I'd like you to pause the video, draw this out if you don't have it in your booklet. You will need practice drawing them out anyway, so that's fine. So draw it out and then label it as you need to. We'll go over the answers in a minute. So hopefully you've gone through, had a chance to give those a label, so we'll go through the answers to make sure you do have the correct answers. So this top one here, the X, is an electron. We often draw an electron as an X, not because it looks like an X, but because if we draw it like a tiny little dot, it's really hard to see. So if we draw it like an X, it's that dot that's in the middle of that X is really the electron, not the whole X itself. Where the X is sitting in that ring, that is the energy level. Also known as the shell. We have here this white one. We know can't be the proton because the proton is positive, so this one must be the proton, and so the other one in the nucleus would be the neutron. And I forgot the E, neutron. And we know the protons and the neutrons go together in the nucleus. If you don't have a paper copy and you're just watching the video, I do need you to make sure that you have this copied down as it is, because you will need to refer to this to answer the questions on the next page. So take your time, draw this out, pause the video, and then give a go to the questions that are on the next page. If you have the digital copy open, you can just use that. So these are the questions I'd like you to give a go to. If you don't have the digital copy or it's not working for you, just write them out on a piece of paper, and then we'll go over the answers in a minute. So hopefully you've had a chance to answer these questions. Again, as with the knowledge check, correct your answers as we're going through. So how many electrons does this atom have? This atom had 3 electrons, 3 crosses. It had 3 protons. If you counted the number of white circles, it had 4 neutrons. How many energy levels does it had? It had those 2 rings around the outside that were called the energy levels. You should remember from last lesson that energy levels are also called shells. So these 2 questions, 4 and 5, were essentially asking the same thing. How many shells, how many energy levels, same thing, both 2. The relative atomic mass of this atom. This is a question that you might have struggled with, but remember how we said that the mass is only in the protons and the neutrons. Because you're not going to notice that grain of sand, one more or less grain of sand on that football. You're not going to notice that mass compared to the mass of the football. So it's the protons and the neutrons. So the relative atomic mass is 7 because we had 3 protons plus 4 neutrons is 7. So which element is this? Because we knew it had 3 protons, so its atomic number was 3, so we know that it is lithium. Why are there an equal number of protons and electrons. We know there's an equal number of protons and electrons because the atom needs to be neutral, which means that the positive needs to be the same as the negative. So, same number of positive protons as negative electrons. Why do we need a second energy levels? Because we have more than 2 electrons. Because we know the first energy level can only hold those 2 electrons. So if we have more than 2, we need another energy level. And the force that attracts the negative electrons to the positive nucleus, that was the electrostatic force. So those are the answers there. Make sure that you do write those into your booklet as you need to, so that you do have all the correct answers there. All right, so now we're going to have some practice with drawing them. Even if you're using the digital copy of the booklet, grab a piece of paper and draw these out, because you're not going to have that computer when you're writing your exams, and you do need practice drawing them. So even if it's a scrap back of an envelope or anything that you have, draw these out. So when we look at the periodic table, we can use that to show the structure of the atom. So we have some of our elements here that we have, and you will need to shade in the protons dark and leaving the neutrons blank. Then you'll need to draw in electrons on the energy levels. Remember that the first energy level can only have 2 electrons maximum. So if you feel like you can give it a go, feel free to go in and give it a go. If you want some more help with it, again, click on the link in your digital copy, watch this video here. Click on that link, watch that video, and then come back to this and we'll give it a go. So hopefully you've given a go to most of these. We'll go through them one by one. As we finish the first one and you notice a mistake that you've made for all of them, I'd like you to pause the video, correct the mistake that you've made before watching the right answer for it, if that makes sense. So we'll start with helium. We have 2 protons and 2 neutrons. So we have 2 protons, so the protons we have to color in dark. So we have 2 protons, 2 neutrons, 2 left blank, and 2 electrons. So 2 crosses on the energy level. Moving on, lithium. So if you've gotten that all correct, well done. If you made a mistake that you know you made on the rest of them, pause the video now, correct the mistake on the rest of them before you keep watching. So lithium, I'm going to shade them in highlighter so that it goes faster. We have 3 protons, so 3 of these circles will need to be shaded in. 2, 3 neutrons. I have 4 neutrons, 1, 2, 3, 4, and I'll have 3 electrons. So 1, 2, and remember the first energy level can only hold 2 electrons, so the third one will need to go in the second energy level. If you've drawn it so that you only have 1 in the first one and 3 and 2 in the second energy level, that would be incorrect. We fill them up from the inside out. So beryllium, we have 4 protons. Again, I'll use my highlighter. 1, 2, 3, 4 protons, 5 neutrons, 1, 2, 3, 4, 5 blank ones, yes, and 4 electrons. So again, start from the inside. Remember, how many electrons can we put in the first energy level? 2. So we have 2 in the first energy level. I have 4 in total, so I'll put the next 2 in the second energy level. You notice here for boron, they didn't give you the circles for you to color in. So we need to draw them ourselves. So 5 protons, 1, 2, 3, 4, 5. I'm going to do my neutrons in a different color. So neutrons, there is a mistake here in the booklet. This should say 6. If you happen to catch that, well done. If not, correct it now, that's absolutely fine. Pause the video, change your drawing so that there are 6 neutrons, and then come back to it. So 1, 2, 3, 4, 5, 6 neutrons, and then we have the 5 electrons. So again, 2 in the first energy level, and then I have 3 left, and the second energy level can hold up to 8, so it can fit all 3. All right, so hopefully you have those 4 done. I'll leave it there for a bit so you can have a look, go back and correct it, and then we'll move on to the next page. All right, so checkpoint. An atom of sodium in the figure has 11 electrons, an atom of argon has 18 electrons. Compare the arrangements of the electrons in the 2 atoms. What I'd like you to do is to type up an answer to this one, or if you just have paper, you can do it on a piece of paper too and take a picture of it, and then email it to your teacher for some feedback. Because of it is the 6 marks, there's so many different things that go into it. So email it to your teacher for feedback, and your teacher can get back to you about how you've done with that. And so last but not least, we have our knowledge and application check. So I'd like you to, again, you know the drill by now, pause the video, write down your answers. We'll go over the answers in a minute. So hopefully you have all your answers written down now. We'll go through the answers for this. Again, I would like you to correct it as we go through so you make sure that you have the correct answers. So the definition for atom, what does that word mean? It means indivisible or cannot be divided. The charge of an electron is -1. The charge on the nucleus is positive. And again, we have no number for the charge on the nucleus because as we've seen this lesson, we can have different numbers of protons in the nucleus. The charge on a proton is +1. The charge on a neutron is neutral or no charge. The subatomic particles found in the nucleus, we have protons and neutrons. The subatomic particles found in the energy levels, these are our electrons. The capacity of the lowest energy levels, how many electrons can we fit in that lowest energy level, is 2. Use your periodic table, name the element with the electronic structure 282. So in the first period is full, the second period is full, and so it's the second element in this third period, which if you look at your periodic table is magnesium. And for the next one, we have our first period is full, our second period is full, our third period is full. So it's the first element, in the fourth period, which is the element potassium. And periodic structure, element with electronic structure. So our first period is full, our second one has 7, so it's the 7th element in period 2, which is fluorine. So again, don't forget to email your answer for that question for the checkpoint to your teacher. Any questions that you may have for your teacher, feel free to email those as well, or message on Milk, or however else you get a hold of your teacher. And we'll see you here for the second half shortly.